All right, people, here are the answers to this. I'm going to try to go over it pretty quick. I'm using my board so we all know how that thing works and doesn't work. So let's get started. All right, here's our formula. If 3 moles of calcium, so I'll put a 3 there instead of the 2, are heated with excess oxygen, how many moles of calcium oxide will be produced? 3 is to 2 as X is to 2. 3, duh. Gotta be harder than this, doesn't it? Number 2, if 20 grams of calcium oxide was produced. Okay, now, this problem right here, this problem is a little bit different. I'm going to get this one out of the way. Well, no, I'm not, because I don't mess you up. If 20 grams was produced, 20 grams of calcium oxide, so we need to figure out how many moles that is. Calcium oxide, we add that together, that's 56. So 20 out of 56. 20 divided by 56 is 0.36. So if 0.36 moles of this, how many moles of calcium, how many liters of oxygen was used? X is to 1 is 0.36 is to 2. So we can write this. So that X would be 0.18. But that doesn't get us there. That's just 0.18 moles. 0.18 moles of oxygen. It said how many liters of oxygen? 0.18 times 22.4. Take my calculator. 0.18 times 22.4. 4. So basically, 4 liters. Let's try another problem. Let's try another one. All right? All right, number 3. I'm going to get this out of our way so that one doesn't look confusing. I'm going to mark this out because I was kind of looking at that one last time. Y'all heard me doing it. All right. If 1 mole of calcium reacts, okay, that's easy. How many grams of calcium oxide were produced? 1 is to 2 as, well, 2. 2 moles of calcium oxide. And the calcium oxide weighs 56. So we got to multiply to get out 112 grams. There we go. All right, let's keep moving on. Questions 4 through 7 deal with these. All right. Let's do this one first. Let's do number 4. If I want to react 220 grams of calcium nitrate, okay, we got to figure out how many moles that is. 220 over 1 times 1 over calcium nitrate. Nitrate is 62, calcium is 40, so that's 102. All right, 220 divided by 102. That's 2.16. I don't know why that keeps happening. 2.16. So 2.16 moles is what that really means. How many grams of calcium chloride could I make? 2.16 is to 1 as, wow, I'm making these too easy. 2.16 is to 1. 2.16 moles of that. But it says how many grams of that? Okay, times CaCl2 is 40 plus 70, so it's 110. Really, it's 111 if you don't round off. So 2.16 times 111. 239 grams. All right, great. Let's try this next one. All right. So I'm down here at number 5. If 39 grams of calcium chloride are produced, all right, so right here, 39 grams of calcium chloride. 39 grams over 1 times 1 over 111. We got to convert that to moles to right there. 39 divided by 111. 39 divided by 111. 0.35. So 0.35 is to 1. How many grams of lithium chloride were used? 0.35 is to 1 as X is to 2. 0.35 is to 1 as X is to 2. So 0.7 moles. That's our X right there, 0.7. And it's lithium chloride. So that's 7 plus 35. So 42. 0.7 times 42. 294. Excuse me, 29.4. 29.4 grams. All right, great. Let's try the last one here. I realize it's probably hard for you to read. There we go. Let's see. Mark this out. Mark this out so we don't get confused. Number 6. If 2.5 moles of lithium nitrate is produced, 2.5 is to 2. How many compounds of calcium nitrate were used? As X is to 1. 2.5 over 2 is X over 1. So that's going to make 1.25 moles. And then it says, how many compounds? Compounds are like molecules, like atoms. So 1.5 times 6.02 times 10 to the 23rd. No problem. 7.5 times 10 to the 23rd. All right, great. We're getting through it. We're getting through it. Now, these problems, now we're doing either Pivnert or ideal gas law. Let's take a look at this first one. 300 milliliters, 1 atmosphere. The temperature force, what is the new pressure? Oh, new pressure. So let's see. We have pressure here, and so we know that we're going to be using the combined gas law because we're asked for a variable twice. So 300 milliliters, that is 0.3 liters because there's 1,000 milliliters in a liter, right? 0.3 liters. 1 atmosphere of pressure, 1. At room temperature. Room temperature is 23 degrees Celsius. I hope you remember that. So we write 296. It is placed in a fire by a demon Boy Scout. The temperature increases rapidly to 473. Ooh, yeah, it gets much hotter. What is the new pressure? Guess what? We didn't even talk about the volume again. You know why? Because it was a can. It was a can that doesn't get bigger or smaller. So volume 2 is also 0.3, or the smart play would be just don't write down the volume either one. This is 1 over 296 equals P over 473. We will cross multiply. 473 divided by 296. 1.6 atmospheres. I don't know why that keeps happening, but it does make me angry. 1.6 atmospheres is the new pressure. All right? I could understand if that was a little bit tricky for you. Number 8. A sealed, empty Coke bottle is laying on the dash of a car. There's only 0.02 moles. Oh, we know we're going to use Pivnert. Pivnert. 0.02 moles. The bottle is 500 milliliters. That's 0.5 liters. And the temperature is 60. That's 333. What is the pressure? Now, most of us, we choose atmospheres. So I'll put a 1 and a 0.0821. Excuse me, what is the pressure? So if we want to solve it in atmospheres, I'll put 0.0821 here. If I put a different number here, like 62.4 or 8.314, that'll just give me the pressure in different units. Since I put this, it'll be atmospheres. That divided by 0.5. Take my calculator. 0.02 times. Why does this keep happening? This is frustrating me. 0.02 times 0.0821 times 333 divided by 0.5 equals 1.09. 1.09 atmospheres. All right, great. Let's keep rolling. This next problem. What is the pressure inside of a oh, we got moles again. This is another PIV. PV equals nRT. All right, no problem. 700 milliliters is 0.7 liters. 0.98 moles. What is the pressure? So again, we can choose our own pressure. Again, I'll put 0.0821. We just default to atmospheres. 33. That's 306. We got to move the 0.7. Boom. Down here. 0.98 times 0.0821 times. I don't know why that keeps happening. It's like I set my calculator down and it jumps up on there. That's weird. Times 306 divided by 0.7 gives me 35. 35 atmospheres. Wow, that would be crazy. It doesn't seem right. Maybe I hit a button on my calculator. 0.98 times 0.0821 times 306 divided by 0.7. Yep, that's right. 35 atmospheres of pressure. That's really high. Oh yeah. It's so small. It's only 0.7 liters. That's why it's so high. All right. How many grams of carbon dioxide are inside a 2-liter bottle? Now, this is a special PIV because it's asking you for grams. All right. So let me go right here and make some room to solve this problem. Okay. PIV. Now we have to solve for moles first. 2-liter bottle, 2 liters, 1.4 atmospheres, again 0.0821, 36 Celsius is 309. How many moles? All right, we're going to take these two, we're going to put them down here using the wizardry of 8th grade Algebra 1. And then we're going to solve it. 1.4 times 2 divided by parentheses 0.0821 times 309 close parentheses equals 0.11 moles. But it said how many grams? Carbon dioxide is 44 grams per mole. So times 44. 4.86 grams. All right, let's keep rolling. We're almost there, y'all. A bottle is sealed at STP. All right, STP is standard temperature and pressure. Its original volume, okay, now we can tell that this is going to be combined gas law because we're getting the data more than once, right? Let's just fill it out. A bottle is sealed at STP. Okay, I'm going to use atmospheres because that's what we always default to. You get some Christmas colors on here. Boom. 1, at standard temperature and pressure. The standard temperature is going to be 273. There we go. 1 and 273. If the temperature increases by 30 Celsius, that takes us up to 303. That's a little bit tricky. The bottle would try to expand. It cannot expand because it is sealed. In other words, we don't have to use volume on this problem. The bottle can't get bigger. What is the new pressure? We're going to solve for P2. Yoink. We end up with just 303 divided by 273. 1.11. Ha ha! I love it when it does that. The new pressure is 1.11 atmospheres. Okay? That's how you do it. I think that's all of them.